Very quick, let's continue. Unsupervised learning. Okay, so unsupervised learning, on the other hand, is the opposite of supervised learning. In this unsupervised learning, this is a situation whereby, in fact, you, the scientist or the AI expert, don't need to label anything. The machine will do everything for you. So you will just train the machine the data, and the machine is able to draw patterns in this data and will be able to actually say this one belongs to that, this one belongs to this. Example, let's take automated car or self-driving vehicles. Now, in self-driving vehicles, you can't label or you don't label anything. The machine does it on it because that one it used on supervised learning. Okay, you are building your car, you want it to be self-driving. Then you go to the car, you feed the machine or the neural networks of your car with data. These are the data you give to it. One, you gave it a data of a human being, of an animal, of road signs, of let me say another vehicle. So a data of another vehicle. Then you gave it let me say trees. Okay, then you gave it data of a road. You gave it to this machine so that it can be intelligent and perform as such. Now you see these types of automated vehicles, self-driving cars, this is how they do. They visualize whenever they start moving. Let me see if I can get a picture for you to demonstrate. I like demonstrating so that you can understand visually. Automated cars. Okay. Okay, this particular example deals with automated vehicles, that's self-driving cars. Now listen very carefully. It means whenever a self-driving car starts, it sends out signals. Now, it has it has sent a signal of another car vehicle. It has sent a signal of traffic light. There, that's a traffic light object. Then it also read what light is on it. It knows the meaning. It has sent a signal of road signs. It has sent a signal of road mappings. These road mappings. It has sent a signal of these mappings too. It has sent a signal of a human being as an object. Now, the designer or the builder of this model has fed this particular machine with all this data. This machine, in its pattern or in its sense, has drawn patterns in this data to the extent that when it starts and it starts emitting this data, whenever it emits traffic signal and it receive a yes, that look, there is traffic here. Now it goes ahead and asks, if there is traffic here, what light is the traffic showing? Now it knows the meaning of the various lights. So if it's red, it knows the meaning. Green, it know. Then if it's yellow too, it knows the meaning. Now it also send a signal of human being. Wherever the human, now listen to something. Whenever a self-driving car is moving, it's defined in a certain parameter. A certain parameter. So let me say you define, or you say send emit signals within 40 centimeters of where your position is. So where the car is positioned, 40 centimeters, anything around it. So let me draw something. Anything around it within this centimeter, within this particular centimeter, it will emit signal. So anything outside this centimeter, it won't detect. Okay, now when it got here, it was able to detect these road signs to know that, look, I've gotten to a zebra crossing. Here, note that the model designer didn't label, he just gave the data. The machine automatically detects this is a zebra crossing, and so the probability of human being crossing is high. Now, a zebra crossing, human being might be crossing. Let me check the traffic. Then it sends signal to, then it asks a signal of the traffic. Is there anything you want to tell me? Then the signal traffic will say, okay, the green light is on. Then the machine will interpret it by itself. Okay, it means I can move. Then it moves. Now, when this traffic light sends that, it tells the machine the red light is on, it means, oh, okay, then I must stop wherever I am. It will stop. It will not move. Now, when is someone talking? Okay, let's move on. Now, when it sends a signal, and the signal brings back that there is a similar object, such as that can be defined as a car in front of it, it makes sure to give a distance. Note, you've given, as a model designer, you've given a distance whereby it should be in whilst on road. So you've told the that machine that whenever you are on the road and within 12 diameter, any car, the distance between you and your next car should be 12 diameter. So there is no way a self-driving car is going to over exceed that distance. So if you've watched a self-driving car, let me say, following another car, there's a defined distance the car will give. Unlike a human being is driving and you see the human being is just at the back. No, they all have defined distance they are in because they've been given data, they've been trained with such data, and in their own processes, they are drawing patterns in this data they've been given. So all what the scientists did is to give a data or to train this particular machine with the data of a human being, the data of a traffic, the data of road signs, the data of vehicles. Then when the machine starts moving, it starts labeling it by itself. This is called unsupervised learning. I just give a data of a car, a human being, a traffic, road signs to my machine. My machine will intelligently use this data whilst it moves. Any question? Okay, if there are no questions, let's continue. One example, another example here is recommendations. Now, I've made this example several and over several times. You visit this Spotify or this Netflix or any of the entertainment things and website or apps you used. Now you will notice when you go to the app, like your first time going to the app, you didn't see any recommendation. But in your second time or third time going to the app, or your future time going to the app, you will see the apps will be giving you things you like. So you mostly go there and watch action movies or adventure movies or romantic movies or drama. The next time you log in, you will see recommendations coming. You see the app will pop some notification that, oh, this movie is nice. And you will check the movie, it is an action movie or adventure. You will see them, it's able to actually detect or draw patterns based on your data that has gathered or based on your previous gatherings. This time round, the model designer didn't label anything. Note here, the machine in itself, in its intelligence, can draw patterns and give recommendations to the user. This is unsupervised machine learning. Again, anomaly detection. Anomaly detection, it comes in so many ways. So let's take an example of money laundering or fraud or let me see scamming or illegal transaction. Now you give a data to your machine, to your model, then you tell your model, your system, based on this, detect if a transaction is fraudulent or not. You didn't label anything. You've just given an instruction. The machine, out of its intelligence, is going to, based on the data given, to predict results. So, for example, you've given a data to a machine that, look, whenever someone is trying to open this door, scan the person's face and make sure the face you've scanned is in your database or you can find a similar pattern in your database. Now you see that particular door, under no circumstance will someone whose information is not in the system can be able to bypass that. The person will be able only if he or she has hacked the system and inserted his or her data in it. That one, the machine has your data and can actually draw patterns with it. But apart from that, there is no way the person can get access to it. Here, you didn't label anything. The machine is using the data it has to draw patterns, to make predictions, to group and say, this picture of this person or this picture I'm taking from this person suggests that this person is a worker here. And so he or she should be granted the access to pass through this particular door. No labeling from you, the model designer. Hence falls under unsupervised machine learning. Any question, please? Please hope you are noting things down. You'll be using these things as we progress. Okay, we are moving on. We have reinforcement learning. In reinforcement learning, it's mostly found in this gaming apps or in apps that rewarding apps. So the more you play and the more you are playing it right, it will be giving you a reward. For example, there was uh this app. So what the app does is it actually rewards students or yes, individuals who perform their homework. So the main motive of this app or the designer who designed this app is to actually make sure people or students or these children can do or will do their homework every day. Okay, now this is it. The student or the user involved will be given this app. Now, as the child or as the person engage with this app, now it's going to detect or it will simply ask the person, you see, have you done your homework? Yes. Okay, if yes, maybe the model developer will say, scan your homework for me to see or scan it. So the person will scan the homework. Okay, when it scans it, oh, okay, this is the work, this is the answer. It's been done. And so it's going to issue candy for the child to eat, or it's going to reward the person with some extra bonus or coins. So this particular form or this particular category is actually used in encouraging activities in our environment. So you are in a community whereby children don't like doing homework, or you are in a community some people say don't like brushing their teeth in their washroom, they come outside and brush. Or you are in a community whereby people just like easing themselves outside of the community. You want to build a model to help solve that particular problem. You will use reinforcement learning. This basically to have an effect on a person's behavior in a defined environment. Let's take our environment whereby people actually don't, let me say, respect putting things in garbage bins. When I talk about garbage bins, you can it's the same as trash cans or let me say, dust bins. Okay, now you as AI experts, what system are you going to build to help change the agent or the users or the citizens in that community's behavior, but in a way that will be rewarding so that it can be very addictive and everyone in that community will be touched to perform the right manner or the right way. Okay, so let me say me for instance, I'll be like, with this, whenever you actually put something in a trash bin, you are going to get some coins in your bank account. So you get maybe say $5 in your bank account. How? Each dustbin alongside the streets is actually attached with this system whereby you can actually scan your credit card with it or your visa card or something, any bank something with it, so that it takes your bank account number then credit it. So whenever someone gets there having a trash can or trash, put in the dustbin, scan it or put it in the dustbin, then just slide your credit card or something, then your bank account will be credited with $5 straightforward instantly. $5. So this model is actually built to help change individual behavior in communities, in cities. So where in a situation whereby you are living in a city whereby children don't like doing their homework, you can build a model that can encourage these children. Maybe you can issue candies. So a child will do a homework, quickly send the homework to this machine, scan it, then a candy will come out of that particular machine and the child will enjoy. This will encourage change the behavior of the users around. So the main purpose of this is to actually help change the behaviors in a defined environment. Any question? Right, very good. We've done so well. We finished machine learning. So all what we've done was about machine learning. And in conclusion, we've learned machine learning, we've learned types of machine learning. We've also learned examples or in real life how to apply this machine learning in real life. Now, on our next meeting, we will be digging into deep learning. Deep learning is a subset in machine learning. So, in machine learning, you find deep learning. Deep learning, and after deep learning, I want everyone to download this app. It's called so you download Anaconda. Let me highlight so you can see Anaconda. Download it on your machine.
This will the phone also be compatible with it?
Okay, those with the phones, I will communicate to you the app you are to download with. So this one is for those on using my computers, either Mac or Windows. You can download the software Anaconda. Those with phones, be checking your Slack channel. I'll be putting a software you are to use also there. So download Anaconda on your machines. We will get there, then we will start using. Our next meeting, we will finish deep learning, then we will get to our software, then we start some practice there. We will start modeling data. We will know our way forward. Okay, ladies and gentlemen, any question? Right. If there are no questions, thank you very much for your time and for joining this class. Have a great evening. Thank you. And whilst you are going, please read about deep learning. And next time you'll finish deep learning. Thank you very much.
Okay, please.
Come again.
I said, okay, please.
Okay, sure, sure. Okay. I'll send the recordings to Blue Coda Club to actually upload it on their channel. Then you guys will get the link whenever you need to revisit what we've learned to understand it more. You can also go and watch it. Then do it. I'll make sure they get it this evening so that by tomorrow morning they'll release it in the various channel. Thank you.